Ladies and gentlemen, hello and welcome, coming to you once again, not quite live from One Take Studios. Today we are back into the world of probability and specifically talking about independent and dependent events. Boys and girls, the word of the day is and. So today's lesson is brought to you by the word and the color purple. Excellent. What does this mean? This means that when I'm talking about independent and dependent events, more than one thing is happening, one thing and another. And perhaps another, as many as you would like, quite frankly, but it has to be more than one thing that's actually happening. So, what might this look like? Well, let's start with independent, and this probably fits your understanding of the word independent. The idea is that the occurrence of one event, so I've got these, let's say we've got two things happening. Whatever happens in the one event is not going to in any way affect the outcome or the probability of the second event. Okay, excellent. So what do I do with that knowledge? Well, here's what that's going to look like. This right here, this is the concept of independent probability. The idea that I'm going to just have this set up with two events, so the events are A and B. Often we use capital letters to represent an event. Notice we can see our keyword is present and. If I'm looking for the probability of event A and event B happening, and in the course of that happening, one of them does not affect the other, I'm going to take the probability of one event, I'm going to take the probability of the other event, and I'm just going to multiply them together, kind of hinging on the fundamental counting principle as far as how many outcomes we have here. All right? So it's relatively straightforward. An example of this, a simplified example, might look something like, hey, I would like to find the probability of drawing a king and a 5 out of a standard deck of cards. If you are working in the world of probability and you don't know what's in a deck of cards, you should probably write that down someplace. But I will tell you that there are 52 cards total, and out of those 52, 4 of them are kings, and 4 of them are 5s. All right, well, there's something else we have to add to this. In order to truly make it independent, we've got what's called with replacement. Okay, with replacement, without replacement, these are very common ideas when you're demonstrating independent and dependent events. With replacement means I'm going to pull a card out, preferably a king, and then I'm going to put that card back. So I'm going to replace the card that I drew the first time, and then I'm going to draw my second card. All right, so think about why that's going to be independent. If I look at the probability of drawing a king, well, we said that there's 4 of those in the deck out of 52 cards. If I put that back and I go to draw a 5, and I'm looking for the probability of drawing a 5, because I put that back, there's still 52 cards, there's nothing that's really changed, and I still actually have 4 5s in the deck, so favorable over total is going to be 52. So again, because I replaced the first card, the second event, there's nothing to affect its outcome. It's still going to be 4 out of 52, just like if we'd started with a fresh deck of cards. So if I'm looking for then the probability of both of these things, so king and 5, well, that's going to be 4 over 52, which by the way is 1/13th, times 4 over 52, which is also 1/13th, for a grand total of 1 out of 169. So the probability of that happening is 1 favorable out of 169 total. Do I want to say that? Yeah, I can say that. So this is going to be my probability. I can write it as a reduced fraction, I can write it as a decimal, I can write it as a percent. Really, any of those should work, and that's going to be fine. All right, so let's compare this then, shall we? If that's independent, what is dependent? What's going to change here? All right, so dependent. Survey says, hopefully this sort of makes some sense to you. All right, so this time we're saying that the occurrence of one event affects the other. If any of you are out there going, she's spelling the word affects wrong. No, I'm not. Effects is usually a noun, and affects is typically a verb. So there are exceptions there, of course, but affects is a verb, so we're saying that the one affects, one changes the other. All right, so, well, doesn't that look very similar to the last one? I think it does. I mean, look at that. We're talking probability of A and B, probability of A and B, probability of A times the probability of B, probability of A times the probability of B. So what's different? That piece on the end, all right? And that's going to actually mean something specific. But again, this is our general format. Again, we've got 2 events happening. I want one and the other to take place. And I'm going to find the probabilities, and I am going to multiply them together. So what we're looking at here is what's called conditional probability. Because these two things are actually dependent, when event A happened, somehow it altered the probability for event B. Ooh, fuzzy. Event B can still happen, but it's going to be different somehow. If you're going to read this, you're going to read it as the probability of B given that A has occurred. All right, so this right here, this is simply a down slash. It's not an operation, it's not the letter I. This is B down slash A, and you're going to read that the probability of B given that A has occurred, indicating something's going to be off here because event A happened. What would that look like in the world of examples? Well, again, keeping this to kind of a simple example, what if we just alter the previous example slightly? Still looking at drawing a king and a 5 out of a standard deck of cards, but this time without replacement. Without replacement, what's that going to mean? The first card that I draw, I'm not going to put it back before I draw the 5, or attempt to draw a 5, I suppose. So if we are looking at this, the probability of drawing our king, if that's our first event, is still going to be, there's 4 kings in the deck, favorable over 52 cards total. Great, awesome, wonderful. But now, because it's without replacement, when I go to draw the 5 out, there are 4 5s in the deck still, so favorable is still 4. However, because we didn't put this card back that we drew, there are no longer 52 cards to choose from. There are only 51. All right, and that does make a difference as far as what the outcome is going to be. You're going to see that here. So if we're talking about the probability of both of these things happening, the king and the 5, but this time without replacement, we've got our 4 to 52, which is also still 1/13th, and this is going to be times 4 to 51, which does not reduce, gives us something delightful of, I cheated and I typed this in my calculator earlier, this is going to be 4 out of 663. So that is definitely not the same probability that we got last time. And it shouldn't be, because something changed, something was different. All right, so things to walk away from here, or walk away with, I should say. Independent, dependent. We have more than one thing happening. Keyword is and. In both cases, you're finding individual probabilities and you're multiplying them together. But with dependent, something affects the outcome of that second one. Okay, so that is a basic introduction. Can it get more complicated? Of course it can. But you got to start someplace, so here we go. All right, thanks. Have fun.